This is Chapter 5, Module 1, the Epidermis. The learning objectives of this module are 1. List and describe the different layers of the epidermis. 2. Describe the events occurring during keratinization that produces a skin resistant to abrasion and water loss. 3. Describe the different skin pigments and how they are produced. 4. Explain the effects of ultraviolet radiation on the skin and how melanocytes protect the DNA of the skin cells. 5. Describe how vitamin D3 leads to an increased absorption of calcium. The integument is the largest system of the body, comprising 16% of body weight. It is made up of two parts, the cutaneous membrane and accessory organs. The cutaneous membrane is the skin and contains two components, the epidermis and the dermis. The dermis is the outer component that is made up of superficial epithelium, while the dermis is the inner component made up of connective tissues. The skin has several different functions that include protecting the underlying tissues and organs, excreting salts, water, and organic wastes through glands, maintaining body temperature through insolation and evaporation, and producing melanin, a protective pigment. Skin also produces keratin, a waterproofing protein, synthesizes vitamin D3, which is necessary for calcium absorption, stores lipids for future energy production, and detects touch, pressure, pain, and temperature changes through sensory receptors. We will discuss these functions throughout this module on the epidermis and the next module on the dermis. The epidermis is the superficial layer of the cutaneous membrane. It is avascular, meaning it doesn't contain any blood vessels. The tissue that makes up the epidermis is a stratified squamous epithelium. The squamous cells of this tissue must receive nutrients and oxygen through diffusion from capillaries that are located in the dermis. The interface between the epidermis and the dermis is not a straight edge. Rather, projections from the epidermis, called epidermal ridges, overlap projections from the dermis called dermal papillae. This overlapping region holds the two layers closely together. The squamous cells of the epidermis are given a special name. They are called keratinocytes. Keratinocytes contain large amounts of keratin and are the most abundant cells in the epidermis. The keratinocytes form several different layers at varying stages throughout the epidermis. Most of the skin found on the body will only contain 4 layers of keratinocytes and is called thin skin. Thin skin covers most of the exposed body surfaces. Thick skin contains 5 layers of keratinocytes, and this skin is found only covering the surfaces of the palms of the hands and the soles of the feet. The layers of skin are called strata. The 5 strata of keratinocytes that are found in thick skin, from the basement membrane to the free surface of the skin, are stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, stratum corneum. All these strata are found also in thin skin, except for stratum lucidum, which is only found in thick skin. The stratum basale is the deepest layer and is attached to the basement membrane. A strong bond forms between the epidermis and the dermis through the epidermal ridges of the stratum basale and the dermal papillae. The epidermal ridges are what form the fingerprints on the digits. The dermal papillae, or tiny mounds, increase the area of the basement membrane and help to strengthen the attachment between the epidermis and the dermis. The stratum basale has many basal cells, or germinative cells, that divide through mitosis to give rise to daughter cells. These daughter cells will migrate up through the layers of the epidermis, changing their structure and their function until they reach the surface of the skin, where they will function as a water-resistant protective barrier until they die and slough off. Other than keratinocytes, there are other more specialized cells of the stratum basale. Merkel cells are receptor cells that are found in hairless skin that respond to touch and will trigger the nerves in the dermis to send the information to the central nervous system. Melanocytes are another specialized cell scattered throughout the stratum basale. Melanocytes contain the pigment melanin. We will discuss melanocytes and how they affect skin color later in this module. The daughter cells of the keratinocytes will be pushed from the stratum basale into the next layer, the stratum spinosum, as the stem cells in the stratum basale continue to divide. The stratum spinosum is also called the spiny layer because the keratinocytes start to lose their cytosol in this layer and the cells shrink or crenate until some of the cytoskeleton sticks out, causing a spiny appearance to the cell. In this layer, there are 8 to 10 layers of these spiny keratinocytes that are all bound together tightly through cell junctions. These cells continue to divide, increasing the thickness of the epithelium. This layer of the epidermis also contains specialized cells called dendritic or Langerhans cells that are phagocytic cells active in the immune response. The spiny cells of the stratum spinosum will continue to be pushed toward the surface as more daughter cells are being produced. The spiny keratinocytes enter the next layer of skin called the stratum granulosum. Here in this grainy layer, the cells stop dividing. In the stratum granulosum, the cells begin to make a tough, fibrous protein called keratin. Keratin is the protein found in hair and nails that make them so brittle and tough. The cells of the stratum granulosum quickly dehydrate and dry as the lack of blood supply negates any osmosis. These dying cells create a tightly interlocked layer of keratin, providing a tough barrier. The next layer is the stratum lucidum, also called the clear layer, which covers the stratum granulosum, only in thick skin, on the palms of the hands and the soles of the feet. Stratum lucidum merely adds more layers to make the protective barrier thicker in these areas. The stratum corneum is the most superficial layer of the skin. This layer is the exposed surface of the skin. It is also called the horn layer and contains 15 to 30 layers of keratinized cells. This layer of dead cells is water resistant. The dead cells will be shed and replaced every 2 weeks as new cells are produced and move up from the stratum basale and the stratum spinosum. Keratinization is the process of keratin accumulating within keratinocytes. Keratinocytes begin their life as offspring of the stem cells of the stratum basale. Young keratinocytes have a cuboidal shape and contain almost no keratin protein at all. As the stem cells multiply, they push older keratinocytes towards the surface of the skin and into the superficial layers of the epidermis. By the time keratinocytes reach the stratum spinosum, they have begun to accumulate a significant amount of keratin and have become harder, flatter, and more water resistant. As the keratinocytes reach the stratum granulosum, they have become much flatter and are almost completely filled with keratin. At this point, the cells are so far removed from the nutrients that diffuse from the blood vessels in the dermis that the cells go through the process of apoptosis. Apoptosis is programmed cell death, where the cell digests its own nucleus and organelles, leaving only a tough, keratin-filled shell behind. Dead keratinocytes moving into the stratum lucidum and stratum corneum are very flat, hard, and tightly packed so as to form a keratin barrier to protect the underlying tissues. This process takes 15 to 30 days for a cell to move from the stratum basale to the stratum corneum. Some areas of the integument are not keratinized. Non-keratinized surfaces must be kept moist by bodily secretions to prevent them from drying out. Types of non-keratinized stratified squamous epithelium include the cornea, the oral cavity, the esophagus, the anal cavity, the vagina, and the internal portion of the lips. The epidermis is the area where water can be lost from the body through perspiration. Perspiration can either be insensible or sensible. The type of perspiration we are all familiar with in daily life is sensible perspiration. Sensible perspiration is when water is excreted through the skin by sweat glands. It is a way to cool the body as well as a way to excrete salts. Dehydration occurs when too much water is excreted. Dehydration can result from the damage to the stratum corneum, such as burns and blisters that result in insensible perspiration. Insensible perspiration is caused by the damage to the tissue that causes the interstitial fluid to be lost through evaporation in the stratum corneum. The larger the area of the epidermis damaged, the greater the chances of dehydration. Dehydration can also be caused by immersing the body in a hypertonic solution, such as seawater, for a long period of time. A hypertonic solution, such as seawater, will cause the crenation of the cells as water diffuses out of the cell through osmosis into the interstitial fluid. Symptoms of dehydration include extreme thirst, dry mouth, irritability, and confusion in adults, or fussiness or sleepiness in infants and children, little to no urination and darker than normal urine, and sunken eyes. Hydration will occur if the body is immersed in a hypotonic solution such as fresh water. A hypotonic solution will cause water to move into the cells through osmosis, causing swelling of the keratinocytes. This swelling will be evident especially on the palms and the soles where puckering of the skin will occur. There are many variations of skin color throughout all the populations of the world. Skin color is influenced by two pigments that are produced in the epidermis, keratin and melanin. Blood circulation in the underlying dermis will also influence skin color as well. Keratin is an orange-yellow pigment that accumulates in the epidermal cells as well as in the fatty tissues of the dermis. This pigment is also found in orange vegetables such as carrots. A fair-skinned baby that eats a lot of carrot baby food may have a slightly orange appearance from the accumulation of the keratin in the skin cells. Keratin can be converted to vitamin A. Vitamin A is important in helping your eyes adjust to light when you come in from the outside, and it also helps to keep your eyes, skin, and mucous membranes moist. Melanin is a yellow, brown, or black pigment that is produced by the melanocytes in the stratum basale. Once the melanocytes produce this pigment, it is stored in transport vesicles and transferred to the keratinocytes. In the keratinocytes, these vesicles will release the melanin and it will surround the nucleus of the keratinocyte, protecting it from the harmful radiation from the sun. The sun emits ultraviolet radiation that can cause the DNA to mutate within the nucleus. This mutation can lead to premature wrinkling of the skin and, in worse cases, can lead to skin cancer. Variations in skin color can occur due to the activity of the melanocytes. Skin color depends on how fast the melanin is produced and not by the number of melanocytes. Individuals with darker skin have melanocytes that produce melanin at a much more rapid rate. They will have more protection against the harmful radiation effects of the sun. Skin color can also be influenced by blood circulation in the dermis, especially for fair-skinned individuals. Blood containing high levels of oxygen appear more red. The oxygenated blood can be seen through the epidermis, especially on the face, where the epidermis is only 0.1 to 0.3 millimeters thick. As blood vessels dilate from the heat, the skin reddens. As blood flow decreases, the skin pales. Cyanosis is a bluish skin tint that is caused by a severe reduction in blood flow or oxygenation to the skin. A person who has insufficient oxygen in the blood will appear cyanotic. For example, the lips can develop cyanosis when exposed to extreme cold. Cyanosis can also be seen at birth if the baby has a heart malformation that prevents the baby's blood from being fully oxygenated. The bluish color reflects the deoxygenated state of the blood. Other things affecting skin color include jaundice, a pituitary tumor, Addison's disease, or vitiligo. Jaundice occurs when there is a buildup of bile produced by liver. Bile will accumulate in the epidermal cells and cause the skin or the whites of the eyes to have a yellow appearance. A pituitary tumor, or a disease of the pituitary gland called Addison's disease, will cause an excess of melanin to be produced, causing the skin to darken. Vitiligo is a loss of melanocytes, which will cause a loss of color in patches of skin throughout the body. The epidermis also plays a key role in the production of vitamin D3. Vitamin D3 is an essential vitamin necessary for the absorption of calcium from food. It is produced by ultraviolet or UV light striking the skin. The stratum basale and stratum spinosum layers of the epidermis contain a sterol molecule. When UV light present in sunlight or tanning beds strikes the skin, it penetrates through the outer layers of the epidermis and strikes some of the molecules of this sterol, converting it into vitamin D3. Vitamin D3 is converted in the kidneys into calcitriol, the active form of vitamin D. Calcitriol is used by the small intestines to absorb calcium and phosphorus. If blood levels of these minerals is low, the bones may become soft and weak, leading to a condition called rickets. Lack of vitamin D may occur in people who live in climates with little exposure to sunlight, or who must stay indoors or work indoors during the daylight hours. Lack of vitamin D has also been implicated in chronic inflammatory conditions such as multiple sclerosis, diabetes, psoriasis, rheumatoid arthritis, inflammatory bowel disease, hypertension, periodontal disease, and certain cancers. Not getting enough calcium and phosphorus in your diet can also lead to rickets. Rickets is rare in developed countries because calcium and phosphorus are found in milk and green vegetables that are readily available in developed countries. This ends Module 1 of Chapter 5, The Epidermis.